Hi, everyone. Today's topic will be a discussion on NSX T Federation with Cloud Foundation on VxRail that has been announced with version 4.2 of VCF. To kind of review the material, we have Philip Armstrong and Cory, both senior principal engineering technologists, if not more senior than anybody else I know. Pretty much the SMEs of the SMEs on this type of topic. So with that, I'm going to hand it over to Phil to get the conversation going. Phil?
Thanks, Jason, and thanks everyone for joining to listen in. We're going to focus on the NSX T Federation. Before we jump into how it works with VCF on VxRail, I wanted to take a quick second to talk about some common use cases that are driving the adoption and the need for this new feature that's announced as a part of VCF 4.2. The first being operational simplicity. As you guys know, more and more customers are deploying VCF on VxRail and multiple different data centers. And up until this point, each one of those from a NSX standpoint are independent sites that are managed independently. The operational simplicity provided by allowing us to use NSX T Federation allows us to administer all of our local instances from a single pane of glass. And we'll go into much more detail about that. But when it comes time to provisioning new networks, security policies, all of that we can do from a global manager UI. And that's really what we're talking about when it comes to a common policy configuration. Many of our customers are looking for a way to push out, say, firewall rules to multiple locations, and having a common place to go and configure those policies in the global managers is something that is a use case that is highly needed. And then, of course, the third one on the slide is another global function, which is allowing our customers to stretch their network beyond a single data center. So if you had multiple deployments of VCF on VxRail, you have workload domains that you need to stretch the network capabilities from one location to the other. NSX T Federation is going to allow us to do this. This is going to enable us to do workload mobility. We're going to be able to achieve things like disaster recovery by leveraging this stretched network capability. Over the course of the next 30 minutes or so, we're going to talk about all of these functions and features in a lot more detail. And the icing on the cake is when we get to the demo, we're going to show you the configuration and how we achieve this, but also we're going to demo this workload mobility from our lab where we set up the NSX T Federation. But before we get into that, let's just take a little bit closer look at what the NSX T Federation is. Like we talked about, the NSX T Federation, many of you may know of the federation that's been included with VCF to federate multiple SDVC managers. And that is something totally separate from this. That's a feature that allows us to log into one SDVC manager and get a view into our other environments. What NSX T Federation is going to allow us to do is be able to create those network segments. And the way that our customers have been doing this today, on this example here, what you see is an example of having 3 locations, right? And this would be 3 different workload domains that this customer would have at 3 different sites. These are all locally managed by the NSX manager. And you see that on the screen, right? Site 1, we have local manager. Site 2, local manager. Site 3, local manager. And what NSX T Federation does is it allows us to deploy something new that's called the global manager. And this is typically deployed in a cluster. As you can see on the screen, we have a global manager primary cluster deployed. And once we deploy this global manager, it's able to manage all of our different workload domains, our local managers. So those local managers could be a workload domain that have a shared instance of NSX, where we have multiple clusters and multiple vCenters using a single NSX manager, or it could be a dedicated instance, depending on the use case that the customer has for their network constructs. So the local manager, when we deploy the global manager, we have the ability to onboard all of the local managers that we need to be a part of that and that federation. And when we onboard these local managers, right, you can see each one of them is going to have a local management. And Cory's going to show us this in the demo, right? So the G is the global manager, the L is the local manager, and all of that is going to be visible from a single pane of glass in our global manager when we log in and do the demo. So now in this situation, we have our global manager implemented, and we have our NSX T, each of our local sites registered. So now we can manage all of our objects from a single pane of glass. So if we want to create local segments or global segments, we can do that all from logging into the global manager. Now there's another component that comes into play because, of course, you know, having high availability is important. So if you look at, and Cory's going to go into detail a little bit later, the way we deploy this is based on the VMware guidance. That's a part of the VMware validated design. And in the VMware validated design, there's a concept of the primary cluster and the standby cluster. So on the screen here, you see the blue global manager is my primary, my active cluster, and the grayed out is my standby cluster. Typically, the way that the VVD says is to deploy your primary cluster in region A and your standby cluster in region B. And that standby cluster is just there ready for failover, a manual failover process, and we'll go through that in a moment. But as configuration is done in the primary cluster, that data is replicated so that the standby cluster is kept in sync in case of a failover event. So we have a primary cluster in region A, a standby cluster in region B. The global manager is connected, right? Once you onboard the different NSX managers, those become local managers. And what that allows us to do is, as an administrator, log into the UI or use the API to make global configuration, right? So that would be for any need to create any new routers or segments or firewalls. As we can see here in the screen, if you wanted to push out new firewall configurations to one or multiple local managers, you're going to do this as an administrator from the global manager. This is unique because instead of having to log into each one of those NSX managers as before, now we can just log into the global manager to accomplish that. And Cory's going to show us that here in just a bit. All right, so global policies aren't the only thing that customers are going to want to use as a part of this NSX T Federation. Global networking, as we talked about, the use cases, is something that, you know, I talk to a lot of people about. And so here, what we're doing is, regardless of if you're creating local network segments, you can do all of that from the global manager, but you also have the ability to create global segments. And in this instance, we have the ability to create a segment that spans multiple sites. This enables you to do things like have workload mobility between these two sites if I wanted to move workloads from one to the other. Or maybe you need to implement a disaster recovery feature, something like SRM, to be able to replicate VMs and failover and not have to change IP addresses. That's something that's common that you're going to see. To be able to implement the NSX T Federation, we need to implement this additional network, which is this RTEP network, which is the remote tunnel endpoint, and what it does is it carries the encapsulated traffic across the site. So that's something when we get into the demo, you'll see that we have that created across all of our sites in the Federation. That enables us to have that overlay network to be able to create these different network segments between each site for that VM mobility, disaster recovery type use cases. We got a great demo of that here in a moment that we're going to get into. Now, before we do that, let's take a look at the architecture of the NSX T Federation. The way we have it broken out is into two components, the management and control plane and the data plane. The management and control plane is as you can see on the presentation, this is where our global managers and our standby global managers live, right? Primary and standby. Also, this is where our local NSX T managers for each site live. So here in Region A, we have our primary global manager cluster, and in Region B, we have our standby global manager cluster, and we have a local manager in each site, right? And if we had more sites than just these two, we would also have a local manager in each of those sites as well. The next is the data plane. And the data plane is where we define our tier 0 routers, our tier 1 routers, all of our network segments. And the nice thing about this is we have the ability to do it in a couple of different ways. Here you see we have a tier 1 router in our Region A. We have one in our Region B as well. Both of those have the ability to have network segments only attached to them. So here in our example, we have Region A only segments attached to our tier 1 in our Region A. Those are egressing into the Region A data center. The same for Region B. We have our Region B segments that are egressing through our Region B data center. When it comes to the multi-region segments, the segments where we're stretching it across both sites, here is the example for that. And these, what Cory is going to show us in a moment in the demo, we have to define which site these are going to egress. And based on the best practices, you're going to egress through Region A for this traffic. So all of our shared segments, regardless of if the VMs live in Region A or Region B, they're going to egress through this tier 1 that's going to be egressing through Region A. So that's under normal operation. Let's look at what happens whenever we have a failure, right? The first thing that's going to happen in a failure is you're going to be impacted, right? So the Region A only segments are going to be impacted because they won't be able to egress through Region A, right? Our multi-region segments are going to be impacted because their egress is the Region A. Our Region B only segments will not be impacted because they're egressing through Region B. We just wouldn't be able to manage those through the global manager because the global manager is down. What happens is the administrator is going to promote the standby global manager to be primary. And now we can manage all of our local managers through our new primary global manager in Region B. So this is where the administrator is going to go and administer the network. And now that we have our global manager back online, the next thing that he would need to do is to configure our multi-region segments to egress through Region B. So he's going to make that change, and now we're back online with our multi-region segments, egressing through region B now instead of region A. So that's how we recover from a network failure. When we restore our network connectivity for region A, it's going to be a manual process to go and promote our standby global managers in region A back to primary. So we're going to do that. And then we're going to go into our global manager and configure the egress through our region A data center, right? So those would be the way we would go and manually fell back to our normal operation. A couple of things that need to be considered before we jump into the demo. We just want to make sure you guys understand these are all important when it comes to awareness, monitoring, and the compatibility, right? So VCF4.2 is the first version of VCF that supports the NSX T Federation. So we have to be at least at 4.2. And this is manual guidance, right? And Cory's going to go over that. You have to follow the VDD. It has manual guidance, right? The automation that SDDC Manager provides when it's deploying a workload domain is only going to stand up NSX managers for that workload domain. The global manager is going to be something that is done through the manual guidance. And then once we have configured the NSX T Federation, ongoing upgrades will require manual steps as well. So the local managers must be upgraded first in both region A and B, and then the global managers are upgraded after all of the local managers have been upgraded. It's recommended that to upgrade the global managers pretty quickly after we've done the local manager upgrade. Now, when it comes to the local manager upgrade, that is a function of SDDC Manager, right? SDDC Manager owns the lifecycle management of everything in VCF stack, right? NSX, vSphere, vSAN, the VxRail components, all that stuff, right? So we're upgrading the VCF management domain and the workload domain that need this function using SDDC Manager. Then once we have upgraded that in region A, we would do it in region B. And then we would manually upgrade the global managers in region B and then region A. After those upgrades are completed, then we would need to do a couple other steps to replace certificates on the global managers and update the local manager certificates in the global manager. So these are, I'm just pointing it out, right? So there's manual processes around lifecycle management. And the same with the backup and restore process. If you guys are aware, SDDC Manager automates the backup capabilities of the NSX managers. The global manager is not, SDDC Manager is not aware of the global manager. So the backup process for that would be a manual process to go and configure, the backups via SFTP server. And of course, we talked about they're not integrated with SDDC Manager backups that we do for the local. And the last one would be password rotation, right? This is always a big deal. Security, rotating passwords every 30, 60, 90 days. Different customers have different policies. SDDC Manager automates this for NSX managers. vCentres, all the, you guys have seen the demos of us doing that. Since SDDC Manager is not aware of the global manager, password rotation for that would be manual. So the path forward would be after passwords have been updated or rotated on your local NSX managers via SDDC Manager, a manual update is required for the NSXT global managers to update the passwords and align it with the new passwords that are set by SDDC Manager. Now I'm going to pause there, and now we're going to jump into a live demo that Cory has recorded using our lab.
Thanks, Phil. My name is Cory Fair. I appreciate everybody being here. We're going to show a quick UI demo of the local managers and the global managers, like Philip was just talking about. We're going to show some of the networking object components that he covered, and just show a little bit of the detail of what it looks like in the actual user interface. And at the end, we're going to show you guys a demonstration of cross-region workload mobility. So, Philip mentioned manual guidance, right? So in VCF4.2, the support for NSX T Federation, as Philip mentioned, is manual only, and all of that is stored in the VMware Validated Design, which is a series of best practice documentation that's published publicly by VMware. This happens to be the site that we used. We can share this information out, but this is the actual guidance that we used. I just wanted to point that out. To log into the environment, you can get to your NSX T local managers through SDDC Manager, right? So you can see we've logged into SDDC Manager here. If we drill into our workload domains, you can actually see the NSX T Manager information, and there's a hot link that you can click on to open it up. And so we're logging into the local manager for region A. We're going to open up another jump host, and we're going to do the same thing for region B, just to illustrate that this is how you get to the NSX local managers. And in the local manager, if you click under location manager, you can actually see that even though we're logged in the local context, it's showing regions, right? So we've already onboarded the local managers for region A and region B to the federated state. So you can see that there's the NSX Global A manager cluster, which is the active cluster. And like Philip mentioned, there's NSX Global B, which is in the standby state. And now we can go ahead and log into the global manager, the primary global manager cluster. Once you're in the UI and you kind of take a look at the inventory, you'll actually see that there's multiple regions, and they're actually outlined. There's a global region, and there's region A and region B. And then under the system tab, which is different than at the local context, you'll actually see, the clusters, the global manager clusters outlined, and then the individual regions outlined as locations, which you can see here. During the setup of this, using the VVD documentation, this is actually the interface where you configure the RTEP network per region. If you click on the global manager appliances, you can actually just get some telemetry about the appliances. What you'll notice about our environment is our cluster only has one manager VM. Now, the guidance for VVD is to actually have three. So you'd have an HA set of 3 per cluster. The reason our lab is like this is because it's a smaller lab with not as many resources. And so we actually built it smaller than the design, but you would typically see 3 appliances, and this is where you add them, right? So, you install the first one, configure it, and then as you deploy the additional 2, this is the user interface where you actually add them. If you click on the location manager again, you'll see more information about the global managers in each region. But what you'll also see is under locations, you can actually see the specific NSX T local managers that are onboarded to that region, right? So this is an interesting point. So even though we're logged into the global manager for region A, there's a drop down in the upper left that actually allows you to pick context. And the context can be global if you want to manage global security policies or global networking objects, or you can actually switch to local on-prem context for each region. And when you do that, the UI here kind of morphs and changes to act exactly the same as what the local manager would. So basically from that single pane of glass, you're able to manage global objects as well as region-specific objects using this drop-down. Finally, on this part of the UI, if you click on Compute Managers, you can see this is where you, under the Fabric section, this is where you actually associate the global manager with the vCenter for the primary region. And you can see that we've come in and actually associated it with VC1 for region A. So we're going to talk a little bit about the actual global networking objects now. Again, we're logged into the global manager for region A. You can see that there's just a summary of the various objects. If you click on the networking tab in the upper left, we've got tier 0 gateway, 3 tier 1 gateways. And so we're going to kind of walk through those. So if we click on the tier 0 gateway, you can see that there's just one, right? And if you think back to Philip's slide where he was showing the various distributed routers, there was just one tier 1 gateway across the entire data plane, right, across the whole region. Now, this particular gateway was actually deployed as part of VCF bring up. And one of the prerequisites for NSX T Federation on VMware Cloud Foundation is the use of AVN, or Application Virtual Networks. And if you deploy with AVN, you end up getting a tier 0 gateway created by default. And part of the VVD manual guidance is you essentially, in region A, you promote that tier 0 gateway to become a multi-region tier 0 gateway through manual steps. And then you actually deprecate the tier 0 gateway on region B and you don't use it. If you look at the location data, you can see that it's indicating that this tier 0 gateway is participating in region A and B, and it's also existing on the edge cluster in region A and the edge cluster in region B. And it's operating in a primary mode in both regions because data needs to be able to travel inbound and outbound from both regions. So if we open up the routing tabs, you'll see that this is the networking construct in NSX that actually peers with your physical layer routers, right? So in this case, we've got a local autonomous system ID. We're using BGP for dynamic routing, and there are again, since this router exists in both regions on 2 different separate edge clusters, we've actually got 2 BGP neighbors per edge cluster up to our routers, and that enables turning on equal cost multipathing, et cetera, for load balancing. And so it's really like a truly distributed router. So we're going to click on the tier 1 gateway, and you'll actually see that there's 3 here. When you deploy with AVN during Cloud Foundation bring up, you end up getting a tier 1 gateway deployed, and you'll get one for each region separately, and it's local to that region. And so you can see that this top one here is the local tier 1 for region A. This second one is the local tier 1 for region B. And that's where that region-specific traffic is going to be routing through. And then AVN also deploys what's called a cross-region tier 1 gateway. And so this cross-region, we're going to kind of expand that one out a little bit. You'll see that it participates in multiple locations. So you can actually see here that much like the tier 0, it exists in both regions. It exists on both edge clusters in both regions. But here you'll see that the region A location and edge cluster are primary. And this is where you get that sort of directional egress, right? So that you only egress out of the primary region's data center, which is what Philip was talking about on the data plane slide. And this is how you control that. And if, you know, there was a failover event, et cetera, you know, you would need to come in and manually change this to remediate the failover. So we're going to go ahead and click on the segments. And, you know, so in NSX, I'm sure most people are aware, you've got VLAN back segments and then you've got overlay segments. So the VLAN back segments that you'll see here are actually created during VCF bring up. You can notice that they have VCF in their name, and they're generally there for transit networks for BGP traffic, right? And so you'll have one per VLAN per region, and we have 2 VLANs and subnets for BGP peering, and so let's end up with a total of 4, 2 per region. And so most of the BGP traffic actually traverses these VLAN back segments. You'll also notice that there's a local region overlay segment created in case you want to do overlay traffic in, you know, within the region between different racks or different subnets, L3 domains. And then you'll also see finally that there's a cross-region overlay. Again, this gets created by the AVN during bring up. And then with the manual guidance that we've applied to enable federation, we've sort of promoted it to be multi-region. And again, you can see that it participates in both locations as well as transport zones in each location. So that's the sort of end of the UI overview for the global manager for sort of setup and global networking objects. We're going to move on and sort of finish up the demo with cross-region VMotion. So we were able to build this out in our lab, and you know what we've got set up is a Windows VM. We're gonna move from region A to region B. We're going to connect to the vCenter to start that process. We get there from SDDC Manager, and you can see it's Windows cross-region. What we're going to do is start a ping from the Windows box out to the management gateway for the entire environment, which means it has to traverse the tier 1 network, the tier 0 network, BGP to the TORs, and then over to a physical router's IP address on a different subnet. And we're also going to start a ping from this jump box in the reverse direction back through the gateway, management gateway, all the way back up to the 192.118.16 network, which is our cross-region overlay network. So we're sort of pinging in both directions, and we're going to start the cross vCenter, cross-region VMotion. You can see we picked the cluster in region B. One of the important things is that you make sure that you select the cross-region segment. So really the source network and destination network should be the same. They shouldn't change. That's the expectation. So once we start this, we're going to bring up our ping. And we're going to speed it up a little bit. And you can see that the VMotion is going along. It's actually going to finish pretty quickly. Yeah, there we go. And you can actually notice that, when it cut over, there was exactly one dropped packet for ping. And we can connect over to the VM's console on the new vCenter because it has been disconnected from this one. And we can actually check what the outbound pings look like. And so if we look at this, you can actually see that there were no drop packets at all. There just happened to be a particular point where there was some high latency up to about 800 milliseconds. I think it's up a little bit from here. Yep, there it is. So that's when the cutover happened right then. Honestly, cutting between regions with minimal dropout is really impressive. So I'm going to stop my share and hand it back over to Jason.
That's awesome, Cory. That's really cool. Pretty powerful stuff right there. So I want to thank you and Phil certainly for taking the time and walking through that. I hope everyone found that helpful.